Hi everyone, this is Judy Warner with Altium's OnTrack podcast. Welcome back. If this is your first time, we're glad to have you. Before we get going today, I've got a great guest for you, but before we get going, I wanted to remind you to please subscribe to this podcast, and you can follow us on iTunes, on your favorite RSS feed, or whatever app you like to use for your podcasts. Today I have with me Tara. Oh, before I get going on Tara, I wanted to also say, please follow me on LinkedIn and also on Twitter. I'm at Altium Judy, and Altium, you can also follow us on Facebook, Twitter, and LinkedIn. Okay, Tara. Hi, my friend.
Hello.
So good to see you. Welcome to La Jolla, California.
Thank you.
So Tara she's a dear, dear friend of mine in the industry. There's not many of us women that have actually been in the printed circuit board business and understand how circuit boards are made. But we do indeed know how that's done, and Tara owns OmniPCB. She's based in the Minneapolis area, and she is a real flex expert, and we've been friends for, how long has it been now?
I don't know, 6 or 7, 8 years?
Probably something like that. Anyways, Tara and I met at a trade show and instantly started introducing each other to our friends and colleagues, and next thing you know, we just created this synergy, and we both have written columns for iConnect 007. Tara has an event in Minnesota called Geekapalooza,
which Judy helped bring out to California.
So I brought it out here to Irvine, and then we brought it together to Boston. Mm-hmm. So we've had lots of professional adventures together. So it's my joy to have you and for us to learn more about your expertise in flex. So how are you liking La Jolla? I know you're here for a few weeks. I bet you're glad to get out of the snow.
Oh yeah, it's no hardship to leave Minnesota winter this time of year, and loving the sun and the beach.
So
it's beautiful.
What was the temperature when you left?
-5, something like that, and slippery roads, and cars were going in the ditch as we're driving to the airport. I'm like, just please make it there so I don't miss my flight.
Oh my gosh.
And I landed here, it was sunny and beautiful.
Right. I know. That's why we like it here. It's expensive to live here, but we love it. So welcome to the La Jolla office. Anyway, so we want to talk today about your deep knowledge on flex circuits, which are becoming more and more commonplace, right? You and I started out in our careers really focusing on rigid FR4, very standard boards, but it's really evolved now.
Oh yeah, flex is a significantly growing portion of the market.
And what do you think's driving that?
Oh, space, weight, packaging. It's small. It can be smaller, lighter, folded. It's really perfect for all of those electronics, the handheld electronics, medical devices.
Right. So what would you say, give us an overview. You just said medical devices. What other things are you seeing an uptick in the flex market?
Really across the board, across all industries.
Really?
Absolutely. We've got companies that have been working with flex that are developing maybe more complex flex or rigid flex, and easily once a week somebody's contacting me brand new, just trying to figure out how to work with flex and how to design flex and what's different, what do I need to know. So a lot of new applications cropping up are people that are just trying it for the first time.
Well, that's why we invited Tara to be our flex expert at this year's Altium Live. And we'll share the link below, but there's a really great presentation that Tara gave at Altium Live, and we have the video and her slide deck. So we'll share that at the bottom here so you can check into that later. So let's talk a little bit about that presentation. That was speaking a lot about cost drivers. Mm-hmm. So for the designers and engineers listening, what are some of the just basic overview of what cost drivers are for flex and rigid flex?
Okay, so we often talk about 3 primary cost drivers: materials selection, panel utilization, and technology. Mm-hmm. I kind of like to throw a little bit tongue-in-cheek, but not really, a 4th one in there, which is understanding your fabricator's capabilities and making sure that you're matching their capabilities with your design.
Yeah. That's not just true in Flex, by the way.
True. It's across the industry.
It's across the board.
Yes.
So start with materials. How does that affect?
Okay, so there are
Cost.
just so many materials you can choose from with Flex. But just for this quick discussion, let's focus on the most common, which is copper and polyimide.
Mm-hmm.
So even focusing just on that segment, your fabricators are going to purchase laminates. They come in generally 3 different types, which would be 2 of them are adhesive-based, one with a standard acrylic adhesive, one with a flame-retardant version of that adhesive, and then adhesive-less materials.
Mm-hmm.
So all of those types come in a range. Typically, your copper thickness is going to be 1/4 or a 1/2 ounce to 2 ounces.
Mm-hmm.
It doesn't mean you can't get a flex circuit greater than 2 ounces.
Right.
It just means that your fabricator has to create the material themselves.
Right.
And polyimide thicknesses are generally between 1/2 mil and 6 mil.
When you said your fabricator has to create that, does that mean they actually take the material and plate it up in their
No,
tanks, or you're buying a specialized material from the material supplier?
right. You would buy the polyimide,
Okay.
the adhesive,
Okay.
and the copper,
Okay.
and the thicknesses that you need,
Okay. Gotcha.
and create them.
All right.
So, like I said, huge range of options that you have when selecting materials for Flex.
Right.
So cost drivers, keeping that in mind, why would you choose one over another, or how does that progression go? Typically, the adhesive-based options are going to be a little bit less expensive.
Okay.
Okay, and they are typically used in single-sided, double-sided, maybe 3 or 4 layer Flex. That's where you'll see those applications.
Okay.
As you go into higher layer count or rigid Flex, the adhesive-less material becomes necessary. Highly recommended for rigid Flex.
Okay.
There's a Z-axis mismatch between the FR4 material and that acrylic adhesive.
Oh, okay.
So you don't want to introduce the acrylic adhesive into the FR4 stack-up.
Oh, gotcha. All right.
So that's why your fabricators are always going to recommend adhesive-less materials.
All right. That makes sense.
So it's kind of like cost versus function
Right.
at a certain point
Right.
that you need to keep in mind.
Right. So other than materials, I know, what are other things that help drive the cost? I mean, I think that's what people are afraid of, right? They think, oh, Flex is too expensive, I can't go that way, but they really need to go that route for functionality. And I think really what you taught us at Altium Live was, it's not that cut and dried, right? If you evaluate all these different things, then it may not be as expensive as you think.
Exactly. And as you decide to move to Flex, working with your fabricator on the material side specifically can really help drive out cost. Because looking at just the raw material, you're generally going to be FR, flame retardant material, LF adhesive, and adhesive-less. But if your fabricator is building a lot of rigid Flex, they're going to stock more adhesive-less materials, and your
Gotcha.
adhesive-less material is going to be probably less expensive.
Right.
So they're buying more of it, they have it in stock.
Right.
You don't have to worry about minimum.
And that's the match
Buys.
you're talking about, like
Exactly.
make that match. And so finding someone that does a lot of Flex and rigid Flex
Yep,
is going to
and-
help you right off the bat.
Exactly, and understanding the material sets that they're using. And a great way to do that is to ask their field applications engineering group to help you with the stack up.
Right.
Because if you're not directing them in a certain direction, they will default to the material that they're using,
Right.
most commonly.
Yeah.
So it's a really good way to make sure you're fitting that gap.
Right. So what are some of the other cost drivers?
We look at different types of cover lay. Cover lay kind of follows a
So like explain
progression.
what cover lay is.
So with flexible circuits, there's 2 types of cover lay. So there's a flexible solder mask, which is very similar to our board type solder mask, other
Right,
than formulated to be flexible,
Okay.
but applied the same way. It's a good option for circuits that might be single-sided, double-sided, or less than 2 ounces of copper.
Okay.
Tends to be a little bit less expensive.
I see.
It does have a limitation in flexibility. It is flexible, but if you're having a highly dynamically flexing application, it's probably
Right.
not your best choice.
Right.
But another advantage is it does allow you to form those nice 90-degree angles on your surface mount pads.
Yeah, of course.
But when you need to, we're concerned about reliability for flex life, the polyimide cover lay, so it would be the polyimide that's the same as your base material and a layer of adhesive. That would be the next option that you would want to go to. The limitations on that tend to be because you're drilling or routing that cover lay, you're going to have a round or an oval opening.
Oh.
So as your circuits get more and more dense, it gets more and more difficult. We jokingly call it the Swiss cheese effect.
Yeah.
Right? You drill it and you take off the background entry and there's not enough material there to even hold it together. It looks great on the screen when it's this big, but when the part's little, so your fabricator will watch out for that if you're doing a design. We all do try to minimize that impact.
Yeah.
The circuit board designer may be asked to gang open or make a larger opening over several pads to kind of alleviate that problem.
Right, okay.
And then continuing on that cost spectrum, if you need the polyamide cover lay and you need that individual pad coverage, laser cut cover lay would be the next option.
Okay.
So that allows you to get the nice 90-degree angles for the surface mount pad, much tighter registration.
I would think from a cost standpoint too, in this case, like laser cut, again, a fabricator that doesn't do a lot of production of these kind of circuits may not have that equipment, may have to send it out.
Exactly.
Which drives the price up. So,
exactly.
I could see that would be another benefit to making sure you're finding a fabricator that's really good at this technology.
Exactly.
Okay. Are there other areas? Or did we exhaust that one? I didn't want to
I think
cut
on the
you off.
materials, I think that those are the two primary things to look at is the base material and the cover lay.
Okay. So it's always easy to kind of relate to that if we could hear a case study or an example that you've had, in your career. Is there a couple of stories you could tell us?
Sure.
Okay.
Sure. So there is a medical application, for example, and trying to reduce the material costs, it was designed as a 3-layer rigid flex. Okay, and flex being on the outer layer in that case.
Oh, on the outer layer. Okay.
Because of the 3 layers.
Oh, gotcha. Okay.
So, but then in this case, that required the flex to be button plated to maintain the flexibility, and it required the circuit to have to be sent out to laser cut for the cover lay to maintain the surface mount pads. So those two together required it to be done on a smaller manufacturing panel for the tighter registration.
Okay, gotcha.
So very expensive circuit and very difficult to manufacture. After a review with the fabricator, decided to go to a 4-layer rigid flex, more standard construction. So the material costs are higher, but it eliminated the need for the laser cut of the cover lay. It eliminated the need for the button plating, and it was processed more standard. So although the material costs were higher, the overall cost of that flex circuit dropped dramatically. So
it's not always about look at the material costs and run, right?
Right.
It really is about collaboration, which you and I both, over the course of our careers, have sang that song, in a variety of circuits, right? It's not, but I can see how in the case of flex and rigid flex, it's even more important, right? Because there's all these variables.
Exactly, and that flex and rigid flex tends to be a product that people are a little less sure of themselves when they're designing, have a lot more questions.
Yeah,
so
absolutely.
My advice is always to identify a few fabricators that you think will be good partners and then involve your fabricators early in the design. Because they're doing flex and rigid flex all day.
Right.
They've learned a lot of lessons, so we all might as well take advantage of those lessons.
Yeah, absolutely. And that reminds me, another plug for Miss Tara, is that she writes a column for the PCB 007 magazine, monthly?
Yes.
Monthly. Specifically about flex.
Yep, it's called Flex Talk.
Flex Talk, there you go. So there's another resource and she usually covers a lot of these in that magazine, and I always look forward to reading your columns. So another case study.
Okay, a second case study I can think of is a military application. The product was, I would say, having probably 90% failure in the field after assembly.
Ouch.
So very, very expensive after a fully populated board. And what happened was it's a rigid flex and it was being bent and it was cracking. So back to the drawing board, what can we learn from that? Turns out, simply redid the stack up and went from adhesive-based materials to adhesive-less materials.
Oh, wow.
So it eliminated only 3 mils thickness in the overall stack up, but
oh my goodness.
It was the thickness and the bend radius was causing that cracking. Wow. So by making that one simple change, in that stack up, they've had 300 assemblies completed now with no cracking at all.
And there's the expertise, right? Like, who would know that 3 mills
Exactly.
could fix that problem? I would have never guessed that.
Yeah,
in
it
a million
seems
years.
insignificant, especially
absolutely.
when we're used to looking at thick, rigid boards, right?
Right.
3 doesn't seem like anything
It
at all.
doesn't seem like anything else. That's so cool. Well, thank you. Those are great stories. You know, since you and I started in this industry, there were, I'm kind of shifting subjects now a little bit, and I wanted to talk to you a little bit about women in our industry. So there are far more women in this industry now than there used to be. Mm-hmm. There still isn't that many of us who actually are on the front lines of sales and marketing, that kind of thing. I know I didn't end up in this industry on purpose. I love it. I love the industry. So how did you find your way? I don't think I've ever asked you this.
Here completely by accident.
See? We didn't do this on purpose.
No, my first job out of college was in the accounting department of a flexible circuit manufacturer.
Okay, what was your major?
Economics and industrial relations.
Well, there you go.
I didn't know what a flex circuit was when I started there.
Right.
Because of that, they required me to work out on their manufacturing floor and learn how to build the circuit. So I was out on that manufacturing floor for a few months.
No way. I did the same thing. But
really?
Yes. Oh, so sorry to interrupt you.
No, that's right.
So, but what the first circuit board shop I worked at, and they had this whole language, these terms and things I'd never heard. You know, what is SMOBC? And I'm like, I don't know. Solder mask over bare copper. And so I asked the production manager, I'm going to come in on Saturdays, and he's like, I'll put you in every department. That was like the best education ever. Wouldn't you agree?
Agree, and I totally didn't appreciate it at the time.
Yeah.
But looking back, I would have never learned the process as well. Because I was running equipment, and I'm really terrible at registering cover lay. I've learned this. It's not something I should do. I don't have that hand-eye coordination, but it was a good thing to learn.
Yeah, absolutely. That's so funny. I never knew that about you. So what do you think we can do to sort of encourage, I mean, we're doing a lot to encourage women in STEM and encourage them to become exposed to these types of careers. What do you think would be a good way, or how are some ways that you've seen? Oh, I know one thing you're going to tell me about, right? Okay, so go.
All right.
I already know what you're going to tell me. Before I wasn't thinking about it when I asked the question, but I'm excited.
See how excited I got to talk about it?
I know. I did see your face there. I'm like, oh, you're going to talk about that. Okay, go. This is very exciting.
Okay, the Flex Factor program.
Flex
Factor, put on by Next Flex, so centered around flexible hybrid electronics. They have a program that reaches out to high school kids, and it's an entrepreneurship program that ties in advanced manufacturing. So they go to J-Bill, they get to see all the cool things.
Oh my gosh.
It's a month-long program.
And this is in the middle of Silicon Valley.
Yes.
So fun.
And I believe it's expanding beyond that.
Wow.
I was lucky enough to be on the judging panel at the end of one of their last ones.
How fun.
So much fun. But what it does is it takes students who may or may not be interested in a technical field. They may be interested in marketing or entrepreneurship.
Right.
But it's like a month program. First week they kind of get the charter, and you have to develop. It's about product development. What kind of need do you see around health and human services, and how could you solve it using a product that's using advanced manufacturing? And then they get to go into the fancy J-Bill building and see all the really cool things that they do there.
Yeah.
They tie that into the next step is entrepreneurship at a community college, and the students are actually given college credit for this program. And then the fourth and final week, they need to pitch kind of Shark Tank style to a panel and go through the whole product development process and profit and loss. And I mean, it's an amazing program. And it's so fun to watch kids, who I talked to one girl, Jordan, and she had really no interest in manufacturing or advanced manufacturing or wasn't exposed to it until this program. And now she's got a lot of ideas.
Which is so great. I don't know how kids otherwise would get exposed to manufacturing. And when you go into a facility like J-Bill or TTM, some of these big facilities, I think kids think manufacturing is like a dark, dank building with, I don't know, something awful. And you go in and there's robotics and chip shooters and all this amazing high-tech equipment and these clean rooms, and you have to wear
The whole bunny suit.
And the glasses, and you go in and you're like, wow, this was not what I was expecting. And that's so great. I forgot that you told me about that program and the whole Shark Tank.
Oh, it was so much fun.
Which makes it so much fun. So what did the students pitch? Or like, what are a couple of things that the students pitched?
There was all kinds of different things. They tended to kind of center around babies or athletes.
What?
Well, different injuries that you might have as a student athlete and how to rehab those injuries.
Oh, okay.
Or baby monitoring devices.
Oh, that kind of, okay.
Yeah.
That's funny. So what was the winner? Is there a clear winner? Do you remember?
I don't remember who won for the panel I was on
Okay.
because they didn't announce it the day that I was there.
All right. And so you're continuing now, right, to be involved with this initiative, and is this going to be each year, or how often do they offer
They
it?
do it throughout the year. I think they just had another round that went through. So, and I might mix up the numbers slightly, but I think that the first program that they did, which would have been the fall of 2016, I think they had 8 students participate, and it's teams of 4. So now they are up to thousands of students participating in this program. It's just growing and growing so fast.
We're going to make sure that we put that that website, so you have to make sure and share that, the URL, so people that are listening can look into that. Such an exciting program. And here at Altium, we're doing so much with the universities and stuff, and I love to see it happening. And it's so fun when you see the light bulbs go on. And, we love our industry. We want to keep it vitalized.
Yes, I think this is a great tool for generating some excitement.
I know, I love it.
I want a program for people our age to go back and do that.
Right?
Like, wouldn't that be fun?
Yeah. What do we call it? Like, I don't know.
I don't know.
Oh, no. We'll have to think about that later. Okay. Here's a really wonky question. I think I already know the answer, but I'm going to ask anyway. Are you a nerd or a geek?
Geek.
I asked the woman who runs Geekapalooza. That was like
that was
a
an
really
easy answer.
I know. Okay, but why do you think a geek? Why is it not Nerdapalooza? Like, why do you think you're a geek and not a nerd?
That is an excellent question. Other than geek sounds better than nerd.
See, I know. Well,
it's the general excitement over something that other people
right, like
maybe think
geeking out over something, right? Geek Squad. It's become cooler. I think geeks are cooler than nerds still, like just generally. I think that's the consensus. And my other wonky question is, on a scale from 1 to 10, how weird are you?
Well,
Gotcha.
Pretty high up there, yeah.
So, like, what are some wonky things that make you weird?
Well,
first of all, you're in this industry.
First of all, it's the industry, right? And,
Yeah.
and I laugh because I'll go out to have lunch, a work lunch, and sometimes I think if anybody's listening to our conversations, we're talking about impedance control and stack ups and EMI, and I'm like, they're playing, what are they talking about over lunch?
I know. I posted a video of me talking about fusion bonding on my personal Facebook page, and it blew up, and people are like, who are you? What are those words? They had no idea that I spoke this whole other tech language.
And if you're out of the industry, most of my friends, my parents, my family, they don't know what I really do.
I know. We're going to put this podcast. We're going to put this podcast on your
cut that part out.
Facebook. No, we'll put it on this and see what they think of you on a podcast talking about Coverlay. They'll be like, what? And my final question would be, one thing I know about Tara Dunn is that you love the beach, even though you live in the snowiest place in the country.
I live in a landlocked state.
Yeah, there's that. But I noticed that a lot of technical people have really interesting hobbies. So what kind of things do you like to do with your family, or places you like to vacation or things you like to do in your very few off hours that you have, Tara, because you don't have a lot of off hours.
I
know
don't, but with the job that I have, it allows me to travel quite a bit because I
yeah,
can
yeah.
work
Right.
pretty much remotely from anywhere
Right.
and make that easy. So, yeah, we love to travel. Specifically, the beach is one of my
Yeah,
favorites. Or in the winter, anywhere warm, desert area.
Yeah.
Everything's great. And I don't know what happened this year, but suddenly I become a music buff.
Oh.
I haven't been to a live concert in a few years, and all of a sudden I think I have 6 or 7 things booked.
That's so funny.
I don't know why.
It's because your son went to college and you have a little more free time.
That
maybe.
could be it.
I don't know. I'm picking up new things though. My kids are out to college, so that's probably the reason why. Well, Tara, thanks. It's always a blast to hang out with you, and it's so fun to have you in California.
Thanks for having me
Usually
here.
we're on the phone on conference calls, and we
Yes.
actually get to see each other in person. It's fun. So again, we'll share lots of informative links that Tara has shared on this podcast, and some that she didn't have time to talk about. We'll share them below, so you can tap into all the interesting resources that Tara has. And I want to thank you again for listening and or watching the OnTrack podcast today. Please remember to subscribe at your favorite podcast app. Until then, always remember to stay on track.